Hello students, welcome to Memoneet. I am Saktiswaru, teacher at Memoneet. I am MBBS student of one of the government medical college of Odisha. Let's start our chapter, that is unit and dimensions with physical quantities. Based on directional properties, we have two, that is scalar and vector. Scalar are the quantities which have only magnitude, which are only magnitude. It has no direction here. Okay, example like mass, length, etc. These have only magnitude but no direction. Vector are the quantities which have both direction and and magnitude. Okay, vector are the quantities which have both direction and magnitude, like displacement, force, etc. Okay, then the second one, that is based on their dependent, fundamental or the base quantities and derived quantities. What do you mean by fundamental quantities? Fundamental quantities are the quantities which cannot be derived from any other quantity, from any other quantity. Okay, just like if we say the example of mass, can it be derived from any other quantity? No. Then length, then time, these cannot be derived from any other quantities. But what do you mean by derived quantities? This means these quantities which can be derived from fundamental quantities, okay. Just like example, like if we have force we know that mass into acceleration is the force. Okay, then we can also write the acceleration is velocity upon time. We can write also velocity. Okay, these are the derived quantities. Units of physical quantities, it is fps, or it can be known as the british engineering system. Okay, British engineering system. In this, we take the length as foot, then the weight as pound, okay, and the time as second. Why it is known as FPS, okay. Then CGS, it is also known as Gaussian system. Gaussian system. We take the length as centimeter as our unit scale here, then weight as gram, and time as second. Okay, then the third one is system. Okay, in this we take length as meter, then weight as kilogram, and time as second. Then the last one, we have the SI unit, or the standard units, or it is derived from the international system. Okay, it can also be known as international system. In this, we take the SI units of length as, that is meter, then length as meter, and weight as kilogram, and time as second. But it correlates with the MKS system, because it is just the modification of MKS system. This MKS system, there is 4 fundamental system and 2 supplementary system are also added in the SI units. Okay, Here, the SI based quantities and their units. The first one is length, that is unit is meter and symbol is m. Okay, small m. Then mass, unit is kg, unit is kilogram and symbol is kg. Then time, unit is second and symbol is small s. Okay, here these are the SI unit. Okay, and temperature, for temperature that is Kelvin and symbol is capital K, mark it. Okay, capital K. Electric current, this is also a SI-based quantity. We have unit as ampere and symbol as capital A. Okay. And luminous intensity, that is unit is candela and symbol is CD. And the amount of substance, that is mole and symbol is mole. Okay, MOL. Classification of units. In classification of units, we have fundamental or base units. These are the units of fundamental quantities. Units of fundamental quantities as seen as the SI unit also. Okay, and let's say their example is length, then meter, then kilogram, etc. And derived units, these are the units which are of derived quantities, that is, it can be derived from the base quantities. Okay, derived from the base quantities. Just like example, let's say we have force here. Force, we know that mass into acceleration, and we know that acceleration is equals to that is v upon t, velocity upon time. We have the unit of force as meter second square. Okay, meter second square, meter length into second square, that is kg meter second square. This is the unit of force, but we can write also it as the Newton, which is the derived unit. The unit are named on the honor of the great scientist. Okay, then supplementary units. Two supplementary units in our SI system, that is radian and steradian. Okay, so radian, what is radian? Radian is the angle subtended by arc in its center. And what do you mean by steradian? Steradian is the angle, solid angle subtended in sphere. Okay, solid angle subtended at center of sphere. Sorry, it is at center of sphere. Units are derived for both fundamental and derived quantities. Okay, just like we have the light year. Light year is the unit of distance, which is a practical unit. We have the horsepower, unit of power. Okay, so these are the practical units. These are the units which are not used for physical quantities, not the same nature as of the physical quantities for which they are used. Just like example, like kg weight. Okay, improper unit of weight. Okay, so start with the dimensions. Dimensions of a physical quantity are the powers or exponents to which the base quantities are raised to represent that quantity. Okay, dimension, what do you mean by dimension? It is the power of the quantity to which it is raised. Let's say we have velocity. Okay, here velocity, we know that it is velocity is equals to length upon time. So the what is the power of the length here? The power of length is L1. Okay, here 1 is the power of length for the velocity, and what is the power of the time here? It is t to the power minus 1. Okay, minus 1 is the power or the dimension of velocity here. Okay, so dimensional formula. What is dimensional formula? This represents how and which type of base quantities are included in that quantity. Okay, what do you mean by dimensional formula? Let's say we have the velocity here. We have the dimensional formula, that is L t to the power minus 1. It is always put in the square bracket. Here this length and the time are included in this quantity, that is of velocity. Equation, what is it? It is the equation obtained by equating of physical quantity with its dimensional formula. Okay, so let's say we have force here. Force is equals to m l t to the power minus 2, which is under the bracket here. M L to the power minus 2, it is the dimensional formula. Okay, and the force, the mass, length and time are dimensions here. These are dimensions. Okay, and we are equating this, so this is known as dimensional equation. There are some questions here, that is dimensional formula we have to find out of density. Density, we know that density is equals to mass upon volume. Okay, so we know that mass is represented as m, capital M, and for the volume we have L to the power 3. Okay, so we can write the dimensions here, that is m L to the power minus 3, as it is brought into numerator, and t to the power 0, because this is independent of time. For the torque here, okay, let's say torque, we know that the formula is R cross F. Tau, torque is represented as here, that is tau is equals to R cross F. Okay, so R is the length here, and for the force we can write length into, for the force what we can write, mass into acceleration, that is m for the mass, and acceleration is L e to the power minus 2. Okay, as acceleration is, we know that acceleration is equals to velocity upon time, and velocity is length displacement upon time. Okay, it means it is displacement upon time. Okay, L upon t square. So this is represented like this. Okay, momentum, we know that P is equals to m into v. So m for the mass, capital M, the dimensional formula will be capital M, and for the velocity here L t to the power minus 1, and it should be put into the bracket. So this is how we can represent the dimensional formula. Then let's see the second question, that is Q is equals to ms delta T. Q is the heat here, m is the mass, s is the specific heat, and delta T is the change in the temperature. So you have to find out the dimensional formula of specific heat. So we can write the ms delta T, we can write mass, for the mass dimensional formula is m, for the specific heat let's say we don't know, let it be kept as it is like this. And for the delta T we have temperature, we have the dimensional formula as Kelvin equals to Q. What is Q? Q is the energy here, so we can write force into displacement is the energy. We can write that is M. What is the value of force? M L T to the power minus 2 into displacement. It means L square will be there. M L square T to the power minus 2. This will be put into the bracket is equals to M into S. The dimension, we have to find out the dimension of the specific heat, and here is Kelvin. Okay, so this will be equals to S is equals to the dimension of specific heat will be equals to, for M to M cancelled out, so we have L square T to the power minus 2, and K, if we replace the K over another side, so this will be in denominator. If we take it to the numerator, it will be K to the power minus 1. So this is the dimensional formula of specific heat. Specific heat, we have the dimensional formula here, that is L square T to the power minus 2 into K to the power minus 1, that is Kelvin. The application of dimensional analysis to convert a physical quantity from one system of the units to another. Okay, so in this, the magnitude of a physical quantity will remain same whatever system is used for measurement. Okay, so what does this mean? We have, let's say we have N U. N is the numerical value of the system, and U unit, that is equals to constant. So if we have if we have the two system, that is we can write N1 U1 is equals to N2 U2. Okay, we can represent, if we have to find out N2, so N2 is equals to N1 U1 upon U2. Also we can write that is N1, that is M1 upon M2 to the power A upon L1 upon L2 to the power B into T1 upon T2 to the power C. The quantity represented as M to the power A and B to the power, L to the power B, if the quantity will be represented as L to the power B and T to the power C. One, that is to check the dimensional correctness of given physical relation. It is if in a given relation the terms of on the both sides have the same dimension, then the relation is dimensionally correct. This is known as principle of homogeneity of dimension. Okay, this means that is the dimension on LHS side, that is left hand side, must be equal to the on LHS side must be equal to dimension on RHS side. It is obviously correct because we cannot equate the force with the momentum or the force with the displacement. So we should equate force with the force. Okay, those which have the same dimension. Then the third one, that is to derive relationship between the different physical quantities using the same principle of homogeneity of dimension. New relations among physical quantities can be derived if the dependent quantities are known. If we have, let's say we have power. power, what is the formula of power? That is force into velocity. Okay, so force here is another derived quantity and velocity is another derived quantity, and to and if we multiply it, we can, and use the homogeneity law, we can derive a new quantity, that is power. We complete all the concept here of the unit and dimension. Let's see some questions here. Here alpha is equals to f v square upon beta square log 2 pi beta upon v square. This quantity is should be dimensionless, as the log, under the log there will be no dimension. Okay, so where f is equals to force and v is the velocity, find the dimension of alpha and beta. We have to find out the dimension of alpha and beta. Extend to this part, we know that 2 pi have no dimension and the dimension of beta is unknown, so beta upon v square, that is velocity square, it means l e to the power minus 1 square. Okay, so this will be equals to dimension, it should be, the whole quantity should be dimensionless, it means m0 l0 t0. so let's compare it. The value of beta will be is equals to l square e to the power minus 2. Okay, so this will be the dimension of beta. The dimension of alpha, let's put it out. Okay, alpha is equals to, dimensional formula for the force is m l t to the power minus 2 into v square, that is l square t to the power minus 2, that is velocity square. So for velocity we write as l t to the power minus 1, and if we square it out, that is l square t to the power minus 2 upon beta square. Beta square is l to the power l2 t to the power minus 2 square. Okay, so this should be equals to m l t to the power minus 2 this quantity and this quantity, got it out. Okay, upon l square t to the power minus 2. So this will be equals to m l to the power minus 1. If we take the length into the numerator, so 1 minus of 2, that is minus 1, and t square cancelled out. So this is the dimension of alpha. Question is asking about, we have to find out the dimension. The dimensional formula for the beta is l square t to the power minus 2. What will the dimension? That is l square and t to the power minus 2. What is the dimensions of alpha? That is m l to the power minus 1 and t 0. Okay, so this is our answer. Next question, if velocity v, force f and time t are chosen as the fundamental quantities, express mass. Okay, so let's see. Mass is the dimensional formula is, it is m10 l0, it's l0 and t to the power 0. Okay, and if we equate with velocity, we know that in which power they are belong to. So for the velocity, we simply write down m l t to the power minus 1 to the power a. Okay, we do, because we don't know in which power they are belong to. Okay, and then for the force, m l e to the power minus 2, e to the power minus 2 to the power b, and for the time, m0 l0 e to the power 1. For the time t whole to the power c. Okay, because we don't know the value of the powers here. So if we compare it out, so we have 1 here, that is equals to, here the m a plus b plus C. Here the m, the value of velocity, that is m0 L1 t to the power minus 1. So here a is a into 0, that is a multiplied with 0 plus b multiplied with 1 plus c multiplied with 0, that is 0. Okay, this is the for the m. Then for L to the power a, here for the second quantity, that is plus b plus c into 0, okay, here it is c into 0. Then for the time t, 0 plus minus of 1, minus of, sorry, it is minus of 1, this is minus of 1 minus of 2b plus c. Okay, so this will compare with the LHS side. So 1 is equals to a, sorry, b, 1 is equals to b, as a into 0 and b into 0, this will be 0. So b is equals to 1, and for the length here in the LHS side it is 0. 0 is equals to a plus b, where b we know that it is 1, so a will be minus of 1, and for the time we have 0 in the LHS side, and that is equals to minus 1, sorry, minus of a, it is not 1 into a, that is a, minus of a is minus of a plus minus of 2b plus c. Okay, so from here a value we have minus 1, that is minus 1, minus of minus 1, that is 1, minus of b, we have the value of b, that is equals to minus of minus 1 minus of 2 into 1 plus c. So if we solve this out, this comes to be c is equals to 1 minus 2, that is minus 1, and if we take it in the other side, that is 1. The mass, in terms of mass, if we represent it out, we have the dimensional formula as a is minus 1, that is v to the power minus 1, and f is for the b is 1, that is f to the power b, that is 1, and for the t we have the power is c, t to the power 1. So this is the dimensional formula in this question. For the energy, we know that m, energy dimensional formula is m L to the power 2 t to the power minus 2 will be equals to velocity, that is L t to the power minus 1 to the power a, and for the force L m L t to the power minus 2 to the power b, and here the time t to the power c. Okay, so if we compare it out, the value of m is, here the power of m is 1 is equals to, here m is 0 plus here is b plus there is no m here, so it is 0, so b will be equals to 1, and for the value of L square, here it is, and 2 is equals to, here the power is a, plus for the second quantity the power is b, plus third quantity is 0, so the value of a will be 2 is equals to a plus b, and b is equals to 1, so a is equals to 1. Okay, and for the third quantity, that is time, the power is 2 to the power minus 2 in the LHS side, that is equals to, in the RHS side we have to compare it out, that is minus of a plus minus of 2b plus c. So the value of c will be equals to, if we solve this out by putting a and b, so it will be 1. So this is our answer for this question. The energy can be represented as the V to the power 1, dimensional coefficient is 1, sorry, it is v to the power 1, then f to the power 1 and t to the power 1. Understood this topic well? Do solve your questions and ask your doubt in Memoneet WhatsApp channel. Okay, bye bye.